Okay, I think we can start now with the webinar. I welcome everybody to the webinar about the Cactus Group Layout. My name is Benjamin Niedermann. I'm a software developer at yWorks and a member of the layout algorithms team. This basically means that I daily work on the layout algorithms, improving them, integrating new features, but I also develop new layout algorithms and new visualization techniques. Today, I would like to introduce you to the newest layout of the yFiles library, namely to the Cactus Group Layout. But before that, I would like to introduce you shortly to the company yWorks. yWorks is located in the southern part of Germany, namely in Tübingen. It has been founded about 20 years ago, and then within these 20 years, it became the leading company for diagramming solutions. So whenever you think about visualizing data, and especially visualizing structured data like networks and graphs, you can use products of yWorks. So for example, the yFiles library, which is a software development kit that is provided for several platforms like HTML, Java, and .NET. And a large part of this library, of this yFiles library, are the layout algorithms. And there are many different types of layouts that you can use to visualize your data. So for example, the hierarchic layout, but also tree layouts, more organic layouts, or also more orthogonal layouts. And today I would like to introduce you to the newest layout of the yFiles library, namely to the Cactus Group Layout. This Cactus Group Layout is very special compared to all other layouts because it breaks with some visualization principles that are enforced by all other layouts. So for example, if you have a look at these nodes, you will notice that these nodes overlap. And this is done by purpose. So for all other layouts, we typically invest a lot of time to ensure that these nodes do not overlap. Here we use this idea to visualize relations between the nodes, as we also will see later in the webinar. Further, we also use this area for routing the edges, so routing the edges through the nodes, which we also normally do not do for the other layouts. So the question is, why are we doing this, and what does it help us, or how does it help us if we do this? And this is what I would like to explain in this webinar. I would like to explain how to use this Cactus Group layout and when to use this Cactus Group layout. And with this, I would like to start the main part of this webinar, namely the part about the Cactus Group layout. This webinar will be structured in 4 parts. Namely, first I will discuss the use cases, then the principles of this Cactus Group layout, and then in the third part I will do a coding example showing you how to use it actually with the yFiles library. And then finally, I will also give you a short conclusion on all of these things that I have explained, and we can also discuss open questions. So first of all, about the use cases. There are many fields where you can use the Cactus Group layout. So for example, for business analysis, so if you want to visualize business data, you can use it, for example, to visualize management data, but also the hierarchies that you have typically in businesses. But you could also use it for science in taxonomies and ontologies, where you also have very structured and hierarchic data. But you could also use it in social media and data science. So basically, you can always use the Cactus Group layout if you have a hierarchy that is tree-like and that is somehow clustered. So for example, you have a topic, and then this topic can be split into subcategories, namely category A, B, C, D, and so on. And then these categories can be split again into smaller groups and so on. And there you can use the Cactus Group layout. This is now very abstract, and I would like to give you a more concrete example on when to use the Cactus Group layout. And for this, I would like to introduce to an application that you probably also can transfer on your applications and on your data, and you can take the basic ideas from this. So for the moment, assume that you're an owner of a sports company and you would like to analyze the sports company and the different fields and topics that are related to the sports company. And one idea, of course, is to do this on a textual basis. You could do this in Excel using Excel sheets, and then create some charts and then compare these charts with each other. But this becomes really fast, overwhelming, and too complex. So the other idea is to use a graph drawing to visualize the structure first of these topics, basically doing a mind map. And of course, you can refine this mind map further and further until you have a really large graph. And in this case, we have the sports company in the middle, and then we have some products, customers, then the stores and the events. And then this is basically subdivided a bit further. So for example, the customers are divided in the age groups, the stores are divided in the countries where we have some stores, and then also into the cities where the stores are, and so on. And this very same you can do also for the products. And if you have different kind of data, so for example, that does not stem from business, but from maybe science or from social media, you basically can do this also for this data often. So this gives you a view on the structure of the data. But of course, now integrating further information, it may become a bit too complex. So what we can do is that we can assign these nodes to groups. So for example, we can say, okay, all the products belong to one group, so one main group. And then the subcategories, so for example, footwear is again a group, and this group contains further nodes like hiking, swimming, running, and cycling, and so on. And so with this, we get a grouping hierarchy on these nodes. And this grouping hierarchy, we would like to visualize a bit more systematically so that we can actually derive information from this very easily. And this is basically the idea of the Cactus Group Layout. So here it's the grouping hierarchy that we basically transfer in the Cactus Group Layout. The idea is that in the middle of this layout, we have the basic group node, namely the sports company. And then the next category, so the next subgroups touch basically this node. So the stores, events, customer, and products, and so on. And this gives us a recursive visualization on the nodes. So with this, we already have some structured information on our company, and this gives us already some information about the structure, but not about the relation between the nodes. So one example could be which customers buy which products in which stores, or which customers do attend which events. And this would be information that could be really interesting when analyzing our business. And for that, we can introduce edges. So for example, here, we introduce for the customers edges displaying relations to the other nodes. So for example, for the seniors customers, the eldest group of our customers, we have introduced this blue tree, which goes, for example, to the stores. And summing up all these edges here, we get all our senior customers. And what we can see at one glance is that most of our senior customers go to the Munich store and buy there. Further, we could also derive from this that most of the customers go to German stores. So basically, it's very likely that's a German sports company that we are analyzing here. And so on. We can do this analysis. Of course, it would be also nice to do this more interactively. And for this, I would like to show you a very short demo. Here, you see basically the same graph, so the same Cactus Group layout. And what I now can do, I can click on the nodes and visualize the edges. So here you get the edges that I've shown you before on the slides. And then I can click, for example, on the senior customers, and then I can see, okay, most of them go to Munich, but most of them also buy, for example, trampolines for their, or attend events, indoor events that are somehow connected to trampolines. And now the next question would be, of course, also interesting. What kind of products are bought by customers that attend such an event? So we can click on this, and then we see, okay, these events are somehow connected to these nodes here, and this basically means, okay, the customers that attend these events buy, for example, here some products or go to these stores. And using this information, we can further and further analyze the behavior of the customers. And this we can do interactively in a very clear way, obtaining information easily. So the Cactus Group layout gives us the possibility to visualize connections between these leaf nodes, for example, and also giving us some possibility to visualize flows, basically going from one node to the other nodes. So summarizing, when should we use the Cactus Group layout? And one thing is, if you have large graphs, it's really helpful to use Cactus Group layouts because they can aggregate information. You can put this information into these group nodes, structure these large data sets, and then you can use this to create connections and relations between the nodes. Especially what we basically need for these hierarchies that we build up on these large data sets are tree-like hierarchies. So we basically need hierarchies that have a tree kind of a tree shape. But then we get clear visualizations of the hierarchy, and the very nice feature is that we can put a secondary graph structure on top of this structure. So for example, if we have here this hierarchy, this grouping hierarchy, we can put another graph on top of this grouping hierarchy, showing these edges here. And then it's also very nice for using for interactive exploration. So for example, for the stepwise expansion of highlighting data flows. And apart from this example, you can also find a demo on our homepage for large graph aggregation. And here you can find the link, and I want to show you this demo very shortly. Here, this is the demo, and here you can use different layout styles for displaying this graph. And here you can also select the Cactus Group layout. And now you can use this Cactus Group layout to interactively explore this graph, for example. So you can enlarge this node, and then you can enlarge the next node. And so with this, you can slowly expand the graph, because you can again collapse the nodes, which gives you the possibility to exploit all your data, but still you don't get a too large and too complex visualization. And this is a really nice demo that you can just try out and play around with it a bit. And this demo you can find on the following link here. So next, I would like to introduce the principles of the Cactus Group layout. So things that you should need to know for using it in the yFiles library. The first thing is that the input is a grouped graph. So basically, the yFiles library offers you the possibilities to group nodes within these folder nodes, and then you can expressed with this grouping hierarchy, so that you have this, that these nodes are contained in this group node, and this group node is contained in the next group node, and so on. This is basically the required input. And of course, you can also add edges between the nodes, which I haven't depicted on this slide because then it would be really cluttered for our example. But you can imagine that there are some edges. And then we also make the assumption that the nodes are represented by circles. This is an important assumption later on to get a nice representation or a nice layout or visualization of this graph. And next, we also, the next principle of this layout is that the nodes use a kind of contact representation for expressing the group hierarchy. This is what I've already said, namely that, for example, the subgroup here, the stores, touch the parent group, the sports company, and so on. And this gives a very clear connection between the nodes. A nice feature of the yFiles library is, of course, that this layout is created automatically and the sizes of the nodes are determined automatically. So you don't need to care about this, but if you want to, you can customize it. This I will also show later on in the coding example. And then there are the edges which are routed through the group nodes. This is also very special here, that you have a very very predefined way how the edges go through the group nodes. Okay, next I would like to present the coding example. I will use the very same example as for the use cases, namely the sports company that we would like to visualize with the Cactus Group Layout. I will do this in 5 steps. Namely, first, I will present the basic setup of the Cactus Group Layout, showing the basic properties. Then after that, I will discuss the label placement and then the group node sizes. And in the last part, I will discuss the edges and the edge bundling. So now I would like to switch to the source code. And this is basically what we get as an input in GraphML file that consists of the grouping hierarchy. The edges are not created yet, but I will do this later on, and also I will describe this later on. The idea is that we will fill this method here, this handle interaction method that is called every time we click on a node. And when we click this, as an arbitrary node, this node is stored in the selected node, and then we can do something with the graph. So the first thing that we can, of course, do is we can just create the Cactus Group Layout. And then we just apply it to the graph with apply layout. And then if we start this, we obtain the following drawing. One moment, I have a typo. It should be layout. And then if I start this, I obtain the following drawing. And as you already see, we have a kind of Cactus group structure, but it does not look very nice. And obviously, it's not a good idea to use rectangles or squares for the nodes, but we should use circles. And this is the basic, or the first step that you always should do is when doing this with the Cactus Group Layout or doing the Cactus Group Layout, to change the style from squares to circles. And this is what I will do first. So there's this method load sample here. And here I basically load the GraphML file. And what I can do is I can comment in this file line here, and this applies a styling on this graph. I won't describe this in detail how this is done, but I would like to shortly show you this method. This is the basic method that is called for each node, and it creates a node style, first determining the color of the node. So this depends on the node itself, but also on the selected node. And then it creates a shaped node style. And here it also says that we would like to have a circle for this node. So when commenting this in this line here, so the styling and applying this again, we obtain already a much nicer graph layout for the Cactus Group layout. And this is the first thing that you need to do when using the Cactus Group layout. So if I click on these nodes, nothing will happen because we haven't said anything about the interaction. I go back to the handle interaction method here. And what I also comment in is the color nodes and edges method. And the idea is that depending on the interaction, it will color the nodes and edges differently. So at the point we don't have any edges, but already in the nodes. So if I click on the customers, for example, all other nodes become blue, and so on. The next thing that I would like to observe is that the nodes around this large sports company nodes are only placed on the top side of this large node, but we don't use the entire space of the nodes. This is because the default value says that the preferred root wedge of this Cactus Group layout is 180 degrees. So this basically means that our graph layout grows upwards. But we can, of course, change this, setting it to 360 degrees. So, and applying this, we attain the next step, namely that the group nodes are placed around the main root node using the entire range of 360 degrees. So this was basically the basic setup of the Cactus Group node. So it's really easy and simple to do, and this was the result that we got. So the next thing that I would like to discuss is the label placement. For the label placement, there are different options, and maybe you have already noticed that for the labels at the leaf nodes, we use radial labels, and for these nodes, we use horizontal labels. But maybe you would like to change this, and I now will show you how to do this. To that end, we can change the node labeling policy. Here we have this property node labeling policy, and we can change it to 3 possible values, namely horizontal, ray-like, and ray-like leaves. And ray-like leaves is the default value. This basically means that all leaf nodes have radial labels, and the group nodes, the interior nodes, have horizontal labels. So if I put this to ray-like nodes, for example, which is not the default, then all of the nodes become all of the labels become radial labels. So sometimes you would like to use these labels, then you can just set the policy. The other possibility is to set all labels horizontally. Sometimes this is really useful to keep the labels legible. If I apply this, you will notice that the labels do overlap, especially the labels of the leaf nodes. The problem is that the nodes are too small, and we need to change the node sizes of the leaves. And this we can basically do by iterating through all leaf nodes and setting them to a larger size. So like this, for example. So we go through all nodes, and we need to check whether this is a group node or whether it's a leaf of the group, so an outermost node. And we can do this by using the graph, and this graph has this method is group node, and we can check whether the given node is a group node or not. And if this is not the case, we would like to set the size of the group node. And here we can use the method set node layout. And then we set here the node and then also the rectangle. And we can set this, for example, to 100 and 120 and 120 pixels. Applying this again, the nodes become larger. Altogether, the visualization become a bit smaller, at least on the screen. It actually became larger. And the thing what you can recognize here is that if you enlarge the leaf nodes, then all other nodes also need to be enlarged so that the leaf nodes can be placed around the parent nodes without any overlaps. So this is always important to keep in mind when using the Cactus Group layout. Enlarging nodes basically propagates through the tree, enlarging all other nodes. So this is also a reason why it's often very useful to use the ray-like labels for the leaf nodes so that the leaf nodes can be small. And this is also what I would like to do in the rest of this webinar. I would like to use the ray-like leaf labels. So for this reason, I just delete this again and use the default behavior. So now you have seen that there are different types of labels, ray-like labels for leaves only, and horizontal nodes labels for the group nodes, but you can have also only horizontal labels, but also the combination. Or where all labels are radial. Next, I would like to show you how to change the group node sizes. So if you have a look at this layout, then you will recognize that these group nodes here have different sizes, and sometimes it's maybe nice for the layout to have the same size. But as I already said, the layout also depends very much on the sizes of the nodes, and this is done automatically. But what you can do is to specify minimum sizes of the nodes. So you can say, okay, these nodes should have at least a certain size, ensuring that they basically have the same size. And this is the next thing that I would like to show. For this, I introduce a node size provider that you can use to specify the minimum size. Node size provider. And this is basically an inode size constraint provider, and I can create it with a static method. And for that, I need to implement an interface. And this interface offers me three methods, namely get maximum size, get minimum enclosed area, and get minimum size. The first two we don't need to take care about, but the last one is the interesting one. So for the first two, I first introduce the imports. So for the first one, I just return infinite in order to express that I don't care about the maximum size. Then for the next one, I also say I don't care about the enclosed area. But for the final one, I would like to express that this is a thing that I'm really interested in for some of the nodes. And when loading the graph, I annotate each node with a level. So for example, this node here has level 0. These nodes here have a level 1. So it's level 1 of the grouping hierarchy. And these nodes here have level 2 and so on. And I would like to set the size of the level 1 and 2 nodes to at least 200 pixels. And I can do this as follows. So I check if the node tag level is 1, or if the node tag level is 2, I would like to return a size of 200 pixels. So the diameter of this circle will be 200 pixels. And in all other cases, I just return 0. Now. No, I'm sorry. I mean the empty size. So this is what I would like to return. And doing this, I forgot to apply this node size provider. I've just created this object, but of course I also need to tell the layout that I want to use it. And to that end, I can access this via the decorator on the graph. And then I can access the node decorator, and there's the size constraint provider decorator. And this has the method set implementation. And here I can add this variable, and then I've set the implementation of this. And now what you can recognize is that all these nodes have at least size of 200, so a diameter of 200 pixels. Especially also the customer node, which is on level 1. The others are a bit larger, but on level 2, they are mostly of the same size. Maybe you have already recognized that this is a property of the graph. So we don't need to do this every time when we do the interaction, but we can do this only once when loading the graph. So I will copy this or move this to the part where I load the graph. And I put this here. After applying the style and setting the graph component. And it still works. And even if we do some interaction. So this brings me to the next part. So we now have set the group node sizes, and another application for this could be that you say, okay, I would like to have different sizes of the nodes for the same level. So expressing some relative difference between the nodes. So for example, you could say that the stores in the United Kingdom have less customers than the stores in Germany. So then you could make the node of United Kingdom smaller correspondingly. And with this, you can further introduce information to the Cactus Group Layout. Next, I would like to go to the edges and show how to add edges to this graph layout and how to style them especially. So I reload this shortly. And as I already said, the edges haven't been created yet for the graph. And I will do this using another data file, not the GraphML file, but here I have a JSON file storing all important relations. So for example, I have this relation store visits, which basically stores for the customers which stores they typically visit. So for example, the first line says that the age group adult visits the store in Cologne, namely 32% of these have done this. And this is an information that I introduce as an edge. And for this, I have a method that is called createTree, or createTree edges. And this expects a node. So for example, the node adult, and then also the relations that I would like to introduce. So for example, the relations to the stores, and then the color that I would like to use. And basically what it does, it filters the relation file for these relations. And then for each of these relations, it creates an edge. And it either can create an edge that goes from adult to the store, so for example, to Munich. But using this property reversed, I can set this to true. Then this edge is introduced from Munich to adult. This will become important later on. And then after creating this edge, I apply an edge style, which basically colors the edge and changes the width of the edge relatively to the percentage. And here the idea is that I use the percentage as an indicator how broad the edge should be. and it can be at most 50 pixels. Width can be at most 50 pixels, but this depends on the percentage of the relation. And then I set the style of this edge in this line. And this method I can call in the load sample file. And I already have written this because I have a lot of relations, and I just want to comment in this. So for example, I can create for the node adult, yeah, this node, all edges that go to the stores using this color, this orange color. And if I refresh the window, I now can click here on the adult and I get this tree showing all the edges that go to these nodes, and some of them have a larger width and some have a smaller width. And of course, I can do this with all of the other relations. So for example, for all adult, for all relations coming from the adults. So I refresh this, and clicking on this, I get the entire tree for this. And this is everything that I need to do. So I don't need to tell the layout how the edges actually go through the nodes, but basically I only need to tell the layout which width the edges should have and which color. And this I've done for all other relations all as well, which I will just comment in at this point. So refreshing this, now I can click, for example, on the customers, and I get all of the edges that I would like to see. And this is a very easy way to already get a very nice drawing. So this described how to use or how to introduce edges. Here it's important also to do the styling correspondingly. But maybe you already have noticed that there are some problems still with these edges. Namely, if we have a look at this node, for example, you may have noticed maybe that the edges lie on top of each other so that we cannot distinguish these edges. And this is what I would like to do. And for that purpose, we can use the edge bundling of the Cactus Group Layout. So edge bundling is a basic technique that can be used to visualize edges such that the common part of edges are drawn together, but at some point the edges split. And the Cactus Group Layout offers us the possibility to do the edge bundling differently for the different groups, so that the single bundles use different channels through the nodes. And this then gives us the possibility to distinguish these groups of edges. So basically, I would like to have this tree of orange edges routed a bit differently than the tree of blue edges, for example. And this is the next thing that I would like to show. And for that, I go back to the handle interaction part here. And then I just want to show you how the bundling can be configured in its basics. So for this, I need a layout data. And this is a Cactus Group layout data. And this I will also add to this apply layout. And when we have a look at this, it's not in the layout data, it's in the layout. I mixed this up. So if we have a look at the layout, there's this property edge bundling, and then there's the default bundle descriptor. And we can use this bundle descriptor to change the bundling a bit. So for example, if we say that we don't use or consider the direction, this is set to true by default. So we change the default behavior. So if I click on this, you may have noticed that there's a slight difference. So I can show you. So have a look at this node here at the customers, if I remove this again, and I click on this, you can notice that these edges don't go through the center of the node, but they go around the center of the node. But if I don't consider the direction of the edges, then the edges go through the center of the nodes. And this is basically what I would like to use to distinguish these different types of edges. And for this, I need to customize the bundling. And now I need the layout data, because the layout data gives me the possibility to define different bundles for the edges. And to that end, I create a bundling. Edge bundle descriptor, it is called. And for this bundling, I say that I would like to bundle it, so the default is false. I can later on show what happens if we set this to false. And then I also say that I would like to consider the direction for this. That I don't want to consider the direction. So this bundle should go through the center of the nodes, while all other bundles should go or pass by the center of the node. And now I need to go through the edges and say which of the edges belong to the bundle. And for this, I can use a delegate or a delegate of the layout data. Here I use the customized edge bundle descriptor. And here I have this delegate, and this delegate basically goes through all edges. And for each edge, I can say whether it belongs to a certain bundle or not. So I can say, okay, if the edge tag relation.source, so this is basically the label that is contained in one of the nodes, is, for example, youth, then it should not belong to the bundle. So for this, I would like to use the normal behavior, the directed behavior. And for the seniors, I also want to use the normal behavior, but for the adults, I would like to define the bundle differently, because the adult node is in the middle of these three nodes. So I just copy this. And this is seniors. So, and for these, I return null. And for the adult node, I return the bundling. So this basically means that I have defined a certain or a customized bundle for the adult nodes, by saying that the direction is false, that they should go through the center of the nodes. So if I apply this again, and I click on this node, you will notice that the orange edges go through the center of the nodes, and the edges of the youth and seniors age group pass by the left of the node. And this is basically what we want to see at this point. So as I said, we need to set this bundle to true, but the question is, of course, what would happen if I set this to false? And then we say that these edges are not bundled anymore. And what you can recognize is that they are represented by simple polylines instead of using Bézier curves in this case. So we set this back to true. And we will refresh this. And now we get this image. So for the orange edges, everything is fine now, but for the blue and red, it's still a bit problematic, because the blue and red overlap each other still. And the thing is that if we consider the direction of a bundle, it passes by the node on the left-hand side. So what I want to do is, for one of the bundles, that it goes or passes by on the right-hand side. of the center node. And for this, I just reverse the direction of the edges, basically obtaining this looking from the other side of the edges. And this I can do when loading or creating the edges. For the seniors here, I just set the reversed to true. So this basically creates edges that have a reversed direction. And if I refresh this, click on this, we now get that the blue tree also separated from the red tree because it passes by the center on the right-hand side. And with this, you can basically separate 3 groups of different edges from each other, expressing different information in the Cactus Group layout. Yeah, and this is basically what I wanted to show for the edge bundling. So the edge bundling helps us to distinguish edges and their routing in the Cactus Group layout. Yeah, this brings me to the conclusion of this webinar. In this webinar, you have seen a very eye-catching visualization for grouped and clustered network data. So whenever you have some kind of tree-like hierarchic data, maybe very large data that you would like to visualize, you can think about using the Cactus Group layout. Especially if you want to visualize further information, so for example, flows between nodes, but also other relations. And with this, I would like to end the webinar. If you have questions about this, then just let us know. So for example, just leave some comments below the YouTube video, and we will try to answer this as soon as possible. And with this, I thank you for your attention, and I wish you happy diagramming.